Okay, so welcome everyone, and thanks Building Smart for choosing our paper, first of all, because today we want to talk about future, something that maybe most of you guys never heard about. It can be a solution for us for like particularly construction and post-construction phases. And today, my colleague Sotiria and me, we're gonna talk about the spatial CDEs and what are they. And actually, to talk about the spatial CDEs, first I would like to introduce you to the Spatial Web. And the Spatial Web is the third generation of the internet. First, we started with the Web 1.0, which was the desktop computing, using internet as a digital library. So we were using pages, searching for data, but the information were static. Later, we switched to the mobile computing. Steve Jobs introduced us to the mobile phones. We started to carry information with us. And right now, we're entering the Web 3.0, which is also like the spatial web, is the computing environment that anchoring data permanently within the physical location in the real world. And why we're talking about it today? Because we have the connectivity, which is the 5G and 6G, and it finally doesn't break the immersion within the immersive experiences. We have the hardwares of AR and VR that finally can work perfectly in the construction site situations. And we have the AI, drones, and all the new technologies that we already spoke about a lot during this summit. And as I mentioned, technology is here, connectivity is here, but what we're missing is the data infrastructure underneath.
In order to achieve this new reality and step into the spatial common data environment, we need to check what happened in the past, in the present, and where we are going to go. In the past, when we started working with 3D modeling, we had the information and the 3D model, but all the information was unstructured, not easy to find. Then we moved on by having OpenBIM, by having IFC and all the standards that were developed in order to have all the data easily move throughout the work cycle and have it structured in order to understand each other, no matter where we're from or the job title that each and everyone has. Now, in the future, we want to step one step further, and instead of having to look for the information in all the file repositories, we want to have the information exactly where we designed it to be, in the physical space, in the structural elements, and in the product. So you can just wear your AR glasses, step into the machine or inside the structure and find the information you're looking for, which could be very useful in emergency situations where there's a problem in situ and we need to solve it immediately. We will not have to look into the file, we just go into the problem directly.
Maybe I'm going to step here, it's going to be easier. Let me just introduce you to the current model of the CDE that we're working right now. So the data are organized by files and folders. They are standardized by the ISO 19650, and actually good information for us while switching to the spatial CDE. This process is staying still, and we're not changing the process. We're changing the way we getting the information from the structure. So right now, when we're on the construction site wearing the AR glasses, what we need to do? We just walking up to the problem, to some element, and we need to open the CDE software, search through the files, search for the folder, for the right version of the IFC folder, parse, mesh, and render. Finally, the geometry is appearing, and then we can see it in the real life. And that's what I'm saying, like we're searching for the data, but what if the data find us? And this is the simplified way of the spatial data graph. So all the entities in the spatial graph, they have these coordinates and the spatial identifier. So the same scenario, you're on the construction site, you're in front of some elements, and you can simply run the spatial query, which is what is here, what are the entities 5 meters away from me, and then the spatial graph returns data, and it overlays the data in the AR. This is fast, the data finds us, and this is instant and AR native. And the good information for also building smart, IFC is the semantic brain. And about the IFC and also OpenUSD, Sotiria is going to tell us a little bit more about it.
Okay, so we saw the concept, but it's really interesting to see what are the tools that we currently have in order to start imagining and implementing some starting points to see how we can get there. We have, as we all know, our beloved IFC, and we also have OpenUSD that we're going to see today how we can combine these two, not trying to replace or remove something from the current workflow. We want to see how these two together can support each other's weaknesses and strengths in order to step one further step into the future. So IFC, as we know, is a great tool that has been developed by Building Smart, and its core strength is semantics. It is able to have all the metadata and the object definitions, helping us understand better where all the information is. But the real big problem is that it's sometimes really difficult, really heavy to load. We know that IDS or MVDs have been developed exactly for that reason, to make our life a little bit easier and be able to filter the information much faster. But this is where OpenUSD comes in. It has been developed by Pixar Animation Studios, and it has been used for gaming because its exact core strength is being able to run very fast, streaming the millions of meshes simultaneously. So we can see here that there is a connection. It is lacking the semantics that IFC has, and it has the streaming power that IFC is a little bit lacking on. So if we combine these two, we can use both their strengths and step into the future of having the information right in front of us, where it's supposed to be, instead of the files.
And we need to also talk about a little bit of a legal part and how to govern all of it, how to safely manage all the AI, drones, human beings in this physical space. And you ask me why I'm talking about the standard of I3E 29874 that was refined in 25 here on the Building Smart Summit. Because currently they established like 4 main blocks, and they all describe how the entities connect to each other, how they communicate with each other, and how they exist in the big map. And this is the place for the Building Smart to step in, to extend the actual usage of the IFC to be portable. So first, this is like a hyperspace modeling language. And this describes every physical space, every human, every objects, and the relationship between them for the machine to actually understand. So for our air glasses, for the drones that can fly and check like the construction site. And all of those entities, they have the special identifier. And also for the IFC, we can extend the global unique identifiers for the spatial IDs to be movable, to be portable. We have the spatial protocols, transition protocols that secure communication between all those objects, all those entities, and they are written by the code. So right now, we need a human to actually decode something, decode some rules, but in the future, we can just launch our drone. He's gonna fly like above some building, try to run the inspection, and automatically he can he can read the law that is written by the code and enforce it automatically. If his spatial ID is not unable to actually enter some restricted area, automatically he's gonna return to the base. And all of this is in this big spatial data graph, which is called Universal Domain Graph.
I see some pretty worried faces in the audience because I think maybe some of you are still thinking that we are talking about some sci-fi scenario. But I'm here to assure you that there have been many movements done by companies trying to implement this new reality. And not only, we're going to see 2 very simple things that have been done in order to move into the new reality. First was the Flying Forward project by EU, implemented in large cities like Milan and Barcelona, where they wanted to check if we can actually remove all the law from the paper and have it encoded inside the drones and have them move around the city by understanding where they are supposed to go and not move freely. And in that way, they help the people in emergency situations or in crowd control when we have really large events where we know how chaotic this can be. So we had technology step in by understanding the spatial environment and step in and help the situation. Second, we have the spatial BIM collaboration format, which is something that was inspired by automatic cars that drive automatically. They use the same idea to understand the space between them, the boundaries, the other moving objects. They know in real time where the object is in order to avoid it or step toward it. So in the same situation, we will have this in the work site, have drones help us, or the people use AR glasses to understand where they should go, what they should do, and help in emergency situations by showing them what they should do beforehand to be safe, so to understand the safety protocols in the first place without the danger of the live construction, and then step into the construction to do that. We are both very, we're both very excited to be here and to speak to you and see if you, your company, or someone who knows something has done something similar, and we want to explore and discuss with you, because we really believe that this is something that could happen in the future and help everyone, the whole industry, to move forward and be safer and also follow the rules more systemically. My name is Sotiria Asaridou, and this is my co-worker, Maja Nizioł. We are working for Telco Advisors, and we're trying to promote and be always at the first step of new innovation and regulations. So we're more than happy to discuss with you and solve any question that came up. Thank you very much for your attention.